Okay, hello YouTube. Why do rigid bodies rotate about their center of mass? Alright, so the definition of center mass, it's going to be some of these formulas. Essentially, you're summing up the mass moments of each particle you're interested in and dividing by the total mass. So if you have some origin point and a position for the center of mass, then the total mass times that position is the net mass moment. So if your origin were at the center of mass, then all of these mass moments would cancel out. And this is going to be important. So it's also sort of like a weighted average of x, or the position of all these little mass particles. So a rigid body, it's going to be rotating in equilibrium. And we don't necessarily know if it's going to be about the center of mass, but we'll show that it will be. So there's no net external force nor any net external torque. This means that omega, the speed at which it's rotating, is going to be 0. And that's pretty much the only condition we need. A small particle will be in circular motion about its center of mass if there is a force. So what is that force? The centripetal force. So let's look at this diagram. Here's a small partition on our rigid body. It has some distance from the point of rotation, we'll see. And it's going to have a mass, and it's going to have a radius from that point of rotation. For it to rotate about that point, it will need a centripetal force. So mv squared over r. This is equal to mr omega squared. Now remember, because of equilibrium, omega is going to be constant. So because there's no net external forces and no net external torque, that this centripetal force is going to have to be an internal force, i.e. Newton's third law says that every action has an equal and opposite reaction. Meaning if we took the sum of all these centripetal forces for each little partition on the rigid body, then it has to add up to 0. You have a force this way, you have a force equal and opposite in the other direction. Now, because of the equilibrium, omega is squared. It's going to be a constant. And now we have this interesting sum. Do we remember that if the point of rotation is the center of mass and r is this vector drawn from the center of rotation to each point, then, well, this is just the mass moments, right? And the mass moments are going to sum up to where the center of mass is. So if we want this to be 0, we should have the center of rotation be the center of mass. Thank you.